Hello and welcome to Algorithm. Today we're going to be solving Leetcode 2781, length of the longest valid substring. This question in short asks for the longest length of substring in a given string that does not contain any sequence of characters found in the forbidden words. So for example, in the given example, the word CB and then 4A, BC has the longest substring of 4 because the longest substring of AABC does not contain any of the forbidden words AAA or CB. Right, so in order to solve this question, we have to look at this at a higher level. So, in order to solve this question, we have to first create substrings and we have to check those created substrings with the forbidden words and check if they are valid or not. So let's go over the first step first. How do we create substrings? So the naive way of creating substrings is the brute force way, which is like creating from the first index and going on to create substrings that starts with the first index, and going to the second index and creating substrings that start with the second index. Now this is obviously gonna take O to the n squared time complexity, and that's not what we want always. And to get a better solution, we can use the sliding window technique, where we have left index and right index, and we iterate through the string once, and we can create different substrings and check the validity of the substring as we iterate through it once. So, in order to create sliding window, we have to consider two things, which is how are we going to iterate the left index and how are we going to iterate the right index. I think we can all agree that iterating through the right index is just checking if there's forbidden words in the substring that was created, and if there isn't one, we iterate to the next index, right? So it doesn't have in forbidden words. We just plus 1 to the right, right? But the iterating to the left index is quite tricky in this case. Obviously, we're going to iterate when it does have forbidden words, right? But the question is, where does the left index go when there is a forbidden word, right? So given this example, let's say that we have iterated through whatever many times and we have reached the substring ABAC where the left index is at A and the right index is at C, right? Then we know that so far the max length is 4, right? And then we go to the next substring, which is ABACB, right? And we notice that CB is indeed in the substring where left and right index is at such. But if we move the left index just like we did with right index by over 1, we still have CB in the forbidden word in our substring. In fact, wherever we move, we'll always have CB at the end of our substring created if we move our left index. What does this indicate? This indicates that we actually have to move our substring left index like such, where B is our new starting point of the substring. And we can indeed check over the string that was given that the longest substring possible is ABAC or BABC, right? And return 4. But let's say it was maybe D here, then it would indeed return 5 because this would be the longest one, right? So that's how we solve this question. Now there's some optimizations that can be made here. So you will also observe the fact that we only have to check the right end of our substring every time, because the moment we have the forbidden word, we'll just go to the new character to start all over again, right? So this indicates that we only have to check 3 or 2 lengths from the end of the substring. So what that means programmatically, this is important because it helps us program it better, but idea-wise it's very obvious. If we're given the substring ABAC, we only have to check the forbidden words, let's say AAA and CB. We don't actually check if ABAC has AA in it. We check if BAC is equal to AAA, and then we check AC is equal to CB. Do you notice that? So that this will help us optimize it better, and you will understand once I start coding. So I think I forgot to mention one little optimization that we'll be doing to our code. So notice how our forbidden words have length of 3 and 2 and 2, right? Then our forbidden word, first one, will iterate through each forbidden word and have length of 3, right? So we'll go to our substring, check the end of our third substring, length of 3 from our end of our substring, BAC, and then we'll check if BAC is equal to AAA. And that's obviously not equal, but in order to check the equivalence, the code will actually go like check B to A, and then realize it's not correct or correct, and go to A and C to A. This is quite inefficient. So the way we're gonna approach this is actually creating a set of forbidden words so that we can just get BAC and then check if BAC is in the set of forbidden words, and if it is, we can say that this is no longer a valid substring because it has the forbidden word. Now we can do this because, and by doing so, we'll actually save a lot of time complexity, because before, by checking equivalence, we'll be approaching this problem with 0 to the m, where m is the length of the forbidden word, the longest forbidden word, to O to the 1, because set operations are, in fact, 0 constant time complexity. Also, in order to check which length of substring we have to get, we're going to further optimize this problem by making another set that has length of each forbidden word. So this will actually equal to 3, 2, and then we'll actually sort it, and by sorting it and making it into a list, we'll make it a set first, we'll sort it, and then make it into a list, right? And this will allow us to do something. For example, let's say we have a substring of B, we check 2, the substring length is clearly smaller than the forbidden word 2, therefore any other forbidden words afterward, because this is sorted, will know that this substring is valid, because how can it have a forbidden word of length of 3 inside a substring length of 1, right? So let's actually get to the coding part. So let's code this up. So we're gonna have forbidden set, and then we're gonna have a forbidden length set. So this is a bit lengthy, so we're gonna create a list of length of each forbidden word for f in forbidden. So this is a list of, forbidden words in length, and then we're gonna make it into a set, and then we're gonna sort this into a list. So for each, now we're gonna have a left index, of 0 and result of 0, so that we're starting out, so our substring is empty at the moment. And then now we're gonna iterate through with right index of the word, right index in range of 1 to length of word plus 1. Now we're iterating through length word plus 1 because substring operations work much like range operations. So it'll go from left to right, and this will have s left, s left plus 1 plus s right minus 1, right? And then if the range operations also have that, and we just operate through like this, what will happen is it'll iterate, until this, right? And if that is the case, it'll produce something like so. Minus 2, because it'll have s left at max, right? So it'll create this, and it'll actually not reach end of the string. So that's why we're adding one, so that it actually reaches to end, right? So for each size in forbidden set, we're gonna iterate through the sorted forbidden length size. If right index minus left index is smaller than the size, this is the case where the substring was b and forbidden words had the length of 2 or 3, then we just break out of the loop because we're done, because the substring is already valid. And then if the length is smaller, what we do is we make a substring, and we get the, I should probably make this into each size, and then we iterate to right index minus each size to right index. This is because we're only going to check the right end of the substring to the forbidden word length, and we check if this is in the forbidden set. If it is, this is not a valid, so we have valid substring, so we have to update our left index to be right index minus left, each size, so it'll come, so here, so if substring is ABAC, and then we have a forbidden word of AC, we want our left index to start at C, right? Because let's make it longer so that we have a better plan here. If it's ACD, we want our left index to start right here where the next index starts, right? So if we do right index minus each size, we'll actually start our left index at A, right? So we don't want to do that, so we plus 1 here. And then we update our result, max of res, and right index minus left index, and then we return. just a typo here. We have to make sorted function, use of the sorted function to create a new list. Huh. Oh, sorry, we should be iterating through forbidden length, not forbidden size, and we actually passed the test. So if you check here, I just ran the code and I passed with flying colors. Thank you very much.